All right, we are in section 5.8 after your quiz, and we're going to tie in with this 5.9 day 1. 5.8 is just a big explanation, and 5.9 actually has all of the problems in it. I'm just going to tie them together. So what you're going to be able to do, or what step we're taking, you've seen this notation before, the integral symbol, and x squared plus 1 dx. So earlier in this chapter, we spent days and days doing antiderivatives, writing the equation with the plus c on the end. Well, we're going to not do the general. We're going to actually use antiderivatives to find the area under the curve. So, if I make the graph here, let's see, parabola up 1 looks like this, because you know that antiderivatives find the area under the curve, and we did it a bunch of different ways. We did it with trapezoids. We just did it with Riemann sums. Now we're going to do it with calculus. So if I want the area, say, between 2 and 5 under that curve, we interval that I want to find the area under, you're going to see these boundaries on the ends of this symbol. So it'll look like this. Find the area under the curve from 2 to 5. To do that, this symbol tells us to do the antiderivative, and then we'll learn what to do with these values. So this all is about the fundamental theorem of calculus. Fundamental theorem. Oops. Calculus. What it does is it finds the exact, and here's key, we've done a ton of approximate areas under the curve, but this way is going to find it exact. Finds the exact area under the curve for a given interval. So here it is. If function f is an integrable function, that means you have a way to get the antiderivative and if g of x is the antiderivative of it, so g of x is going to be the antiderivative of x, then b dx is equal to, take a look at what this is saying. If we do the antiderivative of f, when we write that equation, that's going to be called g. So if we find equation g, all we have to do to get the area under the curve is plug the value of b into g, plug and chug, plug in the b value, get an answer. Then you're going to subtract the answer you get when you plug a in. So think top boundary minus bottom boundary. So it's plug and chug. So not challenging. That might have been a whole bunch of stuff you didn't understand, but it's actually very easy. So let's practice. Let's go back up and do this number 1. So number 1, we're going to find the area from 2 to 5 of x squared plus 1 dx. So don't worry about the 2 and 5. Just do antiderivative like we did at the beginning of the chapter. So remember, power of 1, you just drop the parentheses. We're going to do each term. So the antiderivative is add 1 times by reciprocal. So 1/3 x cubed plus antiderivative of 1 is x. And we always throw the plus c on. So this whole function is now what you would call function g, but we don't need to label it g. And what we're going to do is substitute in, so I use a bar to show that notation, that I'm going to plug in my 2 and my 5. So I'm going to take this through the long way, and then we're going to streamline it. So we're going to put the 5, we always put the top one in first. So 5 first, so it's 1/3 times 5 cubed plus 5 plus the constant of integration. We're going to figure all that out, so it's in parentheses. Then I'm going to subtract whatever I get when I plug a 2 in here. 1/3 times 2 cubed plus 2 plus c. So 1/3 times 5 cubed, not that I can do that. Let's see, that's 5 cubed, I think, is 125. (125) plus 5 plus c. Now I'm going to distribute this negative. I want you to pay attention to what happens. This will be minus, it's going to be 8/3 minus 2 minus c. So combining like terms, I have 125/3. Let's see, that'll be plus 5 minus 8/3 minus 2. I get 42, and you can see my c's cancel out. Final answer here is 42. And I just did all that on a calculator. The important thing here is to notice that the c's canceled out. And is that going to happen every single time? Yes, it is. Because when I plug it in the first time, I get the plus c. The second time, I get the plus c. We're always subtracting. So, from this point on, if there are numbers over here, you no longer have to put a plus c. It's an unnecessary step. Alright, so that's our streamlined, and you're not going to be showing all this work here either. We're just going to use the table feature to find these values for us. So here's normal problems. Let's practice and see how you do. Number 2. We're going to find the antiderivative from 1 to 4 of x cubed dx. Okay, so again, do your antiderivative first. It's a single term. It's the power rule where you add 1 and times by reciprocal. So that'll be 1/4 x to the 4th. Don't have to worry about the plus c, but now I'm going to 1 and a 4. Doing the 4 first. So here's where, and this is an easy equation. You wouldn't have to use the table, but when the equation gets long, I would go to your y equals, type it in. It's 1/4 times x to the 4th. We're going to go table set. I'm going to start it at, I'll go 4. Well, what's that? 4. Go by 1. So now if I go to the table, When I plug in 4, I get 64. Minus, and when I plug in 1, oh, I don't need the calculator to tell me that's going to be 1/4. So my final value is 60 3/4. Okay, practice some more. Derivative or integral from 0 to 3 of the square root of 3x plus 1. Now it's just remembering all those. You do your antiderivative that we practiced before Christmas. So let's rewrite this with the fractional exponent. That'll be to the 1/2 power. For your antiderivative rule, when you have an inside, you have to have the inside next to the dx. Get that set up, throw all that away, then you add one reciprocal to the exponent. So, my inside is 3x plus 1. So, again, you don't have to write this one. You can just see it. I'm just doing it for note purposes. The derivative of the inside is just a 3. So we're going to put a 3 by the dx, which means we need in front to carry along. This all gets thrown away. And now we add 1 times by reciprocal. Keep that multiplier. So 1/3. Keep this the same. Adding 1 to that, that'll be 3/2. Multiplying by the reciprocal of 2/3. No plus c needed. We're going to show that we're going to plug in 0 and 3. And it's always top one first minus bottom one. So, plugging in, go to clear, y equals, that'll be 2/9. 2 divided by, whoops, that's not a 2. 2 divided by 9, parenthesis, 3x plus 1, parenthesis, raised to the, that'll be 1.5, set. 3, oops, not 43, 3, second table. It does the plug and chug for me. I get a 7.027 minus, if I go to the 0 is 0.2 repeating. Do the subtraction here, and I will have 6.05. So that's what I want to see for work. You don't have to show me the plug and chug. I'm assuming you're just doing it on the calculator. Let's throw some trig at you. See how you are at your trig. Number 4. Got antiderivative from pi over 4 to pi over 3. Cosecant squared minus sine dx. Okay, now remember, that's a power of 1, so it's really not an inside here. These are two separate terms. So think as a derivative. If you look on your blue sheet, cosecant squared, cotangent's derivative is a negative cosecant squared. So that means the answer would be a negative cotangent. And you can check. If you do the derivative of this, you will get a positive cosecant squared. And then what has sine as its derivative? Well, cosine's derivative is a negative sign. So you got to decide, do you want a plus cosine here or a minus cosine here? And you just got to play around with it. If this is a positive, when I take the derivative, it'll be a negative sign. So I want a plus here. And then you just got to show pi over 4, pi over 3. So we want the, we can go right to the y, because I got to plug both of them in. So I'll do like I've been doing. Go to the y equals. Clear out what you have. We want a negative cotangent, which is a negative 1 divided by tan x plus cosine x, and table set. We want pi over 3. I'll probably have to come back and do both of these. So pi divided by 3. Let me check my mode. Whoa. Oh, I'm in degree. I haven't used this before. Radian. Okay. Back. Second table. Yeah. Error, invalid data type, table start is not a number. Well, it doesn't like my pi divided by 3. That's just this phone doing that. Let's go. Then let me go 3.14 divided by 3. Close enough. Oh, enter. Maybe I got to hit enter. Oh, I bet I had to hit enter. Table set. What was that? 1.0466. Table start. I didn't see it, did you? Oh yeah, there at the top. So a negative 0.0776 minus, now we go back. I've already got the equation in there. Now we want table start. Table set. We want to start it at pi divided by 4. Enter. Okay. Second table. It's the top one. So I'm subtracting a negative 0.2934. So grabbing a calculator again. Simplify. 0.2155. Okay, next. Number 5. We have an integral from 3.1 to 6.2 of 4x plus 6 to the 5th dx. And again, all it is get your antideriv, plug in your numbers. So you do have an inside this time. So we got this 5 out here. So if u is the inside, the u prime is just 4. So that means you need a 4 with a 1/4. Throw this away. Add 1 times by reciprocal. Keep the multiplier. So the antiderivative will be 1/4. 4x plus 6 times by the reciprocal. No plus c. 3.1 to 6.2. And again, I find a table to be a little quicker than plugging that in twice. So that'll be 1/24. X plus 6 raised to the 6th. Table set. I want to start this at 6.2. I'll come back. Let's see. Well, second table. 6.2, I'm getting, obnoxiously large number. Let's see if my eyes can read it. 3, 5, 5, 7, 0, 7, 5, 2, point. Let's go 8, 7. So 35,570,752.87 minus, now sticking in the 3.1. So I'll table set that back. 3.1. There's another obnoxiously large number. 16946.67. And I've already got these subtracted on my notes, so I'm just going to write it down. 3,953,805. Point 2. Okay, and then our last one is another trig one. I think I'm going to squeeze number 6. We're going to go 0 to pi over 5. Okay, let's go. Oh, yeah, just keep what I got here. Cosine 4x dx. So again, it's just remembering. So that sine has a derivative of cosine, but we do have an inside here. Remember, the angle is an inside. So what we want to do is take the derivative of our inside, which is 4. So we need a 4 by the dx, which means a 1/4 out in front. And now we say, well, what has this as its derivative? So it'll be 1/4 sine 4x. And we're plugging in a 0 and a pi over 5. So one more time with the plug and chug. 0.25 sine 4x. Second table set. 3.14 divided by 5. I know the graphing calculator actually lets you just put in pi over 5. This one's not. 0.147 minus putting in the 0, sine of 0. So that'll be 1/4, so 0.25. So we are getting a negative area under the curve, which will be interesting with tomorrow's notes. So a little cliffhanger here. How can an area come up negative? Because this is going to come up negative. Quit. 0.147 minus 0.25. A negative 0.103. Question mark. Cliffhanger. That will make sense in tomorrow's notes. Okay, that's it for this section.